All right, last video on the product and quotient rules. So let's look at this. Find the derivative of f of x equals x squared e to the x over 3x plus 5. Now what's going on here is we've got a quotient here, but the top is a product of two functions. So we're going to have to use the quotient rule and the product rule together. So let's see. First, we want to use the quotient rule. Now, how do we decide which to use? Here's what you can do. It has to do with the way the function is parsed, but here's kind of a rule of thumb. Think about what you would do if you're plugging in a value for x. You would, if you're plugging in a value for x, what you would do is first you'd work out these two things and this. You'd multiply these together, and then you would do the division. So let's see, plug in, multiply, then divide. This is the opposite order in which we're going to do the derivative. We have to do the division first, or we have to deal with the quotient first, and then we'll deal with what's inside. So let's see, f prime of x, it's going to be low d high. Now, when I do this top, I've got to use the product rule there. So first times derivative of the second plus second times derivative of the first minus high d low over low squared. Now let's clean this up a bit. The top. Before we do anything else, notice. Well, I'll tell you what. Let's do. Let's not try to do anything fancy. Let's FOIL this out. Let's see. First is going to give us 3x cubed e to the x. Outside is going to give us 6x squared e to the x. Inside is going to give us 5x squared e to the x. And last is going to give us 10x e to the x. Then we're subtracting off 3x squared e to the x. And we've still got this denominator down here of 3x plus 5 squared. All right, we should be able to combine some stuff here. Well, actually, there's two things we're going to do. We can combine, let's see, x squared e to the x, x squared e to the x, x squared e to the x. We can combine those three, but we can also factor out an e to the x. So we've got e to the x, and now if we combine these together, let's see. This term, we've only got one with an x cubed, so that's going to be 3x cubed. For x squared, that's where we'll combine stuff. We've got 6 plus 5 is 11, minus 3 is 8. And what's left? Just this one, 10x e to the x. So this is what we've got. This is our derivative. I could factor out another x, but I don't have space, so I'm not going to do it. All right. Okay, let's look at this one now. Find the derivative of e to the x times x squared times sine x. And we haven't talked about the derivative of sine yet, so I'm just going to give it to you here. The derivative of sine is cosine. So let's take this derivative. Now, what we know so far is how to take the derivative of two things multiplied together. But here we've got three things. So we've got some options here. We could split it up like this and treat this as the first and this as the second. Or we could split it up like this and treat e to the x as the first and x squared sine x as the second. It doesn't matter which way we do it. Um, if we do it either way and simplify, we'll get the same thing. So I think what I want to do is split it up like this. So this is my first, and this is my second function. So my derivative, let's see, y prime is going to be first times derivative of the second plus second times derivative of the first. And now when I do the derivative of the first, I have to use the product rule while doing that derivative. So derivative of that first thing is going to be, let's see, first times derivative of the second plus second times derivative of the first. So let's see, what do I have here? X squared e to the x cosine x plus, distributing across here, this will be 2x e to the x sine x, and then plus x squared e to the x sine x. And I could factor out the e to the x if I wanted. I guess I could factor out an x as well. I'm not terribly picky about that kind of stuff. If you left your answer like this, that's perfectly fine with me. So let's see, if we do this, we got x cosine x, 2 sine x, plus x sine x. So either one of these things that's boxed is good. So let's see. One other thing I want to mention. On this one, we had three things multiplied together, and we split it up. It turns out you can use what's called the generalized product rule to do this kind of problem. If you've got three functions multiplied together, what you can do is come over here and basically do this. Notice on this one, the prime is on G, then on F, and then on H. So you can do that, and that'll give you the derivative. If you have four things multiplied together, G, F, H, and K, we do the same thing. We list each of these 4 times. And on the first one, the prime goes on G, then on F, then on H, then on K. And that'll work for larger and larger products. But in general, this one comes in like we could have used this on the example we just did. It's handy to know this, but I don't plan on giving anything where you have to use this, because it gets long. So anyway, that's all I want to say about the product and quotient rule. That's it.